Okay, so for 8.3, we are picking up where we left off with example 2A, or 2C, pardon me. All right, so you had some like this in your homework. Hopefully you got them worked out. We just did the one. So in this one, we're finding the value of each variable. Here, what do you notice about this one? Might be a little harder. Okay, so there's two things we have to figure out. There's two variables, right? We don't know theta, and we don't know the radius. So could we figure one of those out? Because we know the formula, right, is the length, the arc length equals theta over 360 times 2 pi r. Wait, do you know theta?
You can figure out theta because of the 330 thing.
Oh, so we have 330. What kind of measurement is that? What is that for? What part of the circle? Not the circumference, because circumference would not be in degrees. Not diameter. It's the curved part. Yep, that's the measure of this curved part from here all the way over to here. The major arc, yes. Okay, so that's our arc measure. Okay, for the major arc, but we also know what about the arc measure? It's Noah's arc, possibly. What else do we know about the arc measure?
It's the exact same as the central angle.
It's the exact same as the central angle. So this angle in here is also 330, which means theta is equal to what?
60. No, yeah, 30. No.
Theta is equal to 30, right? Because it's 360 minus 330 equals 30 degrees. Glorious. All right, very nice job. So now we can start plugging in to our arc length. Okay.
So 4 equals.
Ooh. Good. So 4 is our arc length here. So that's our L. So 4 equals theta divided by 360 times 2 times pi times the radius. And I don't know why I wrote theta when we just solved for it. What was theta? Thank you. Okay, so 4 equals 30 divided by 360 times 2 times pi times r.
Make 30 over 360 1 over 12.
Okay, so we can say that 4 is equal to 1/12. You guys agree with that? Okay, and then we have 2 pi r. Divide by 2?
Yeah.
On both sides?
Yeah. No. Yeah.
Okay. So we're going to divide the 2 out. So 2 equals 1/12 pi r. Okay, do we divide by 1/12? So we're going to multiply by 12 over 1 by both sides. So we would have 24 equals pi r. 24 pi does not equal r. We have 24 equals 24 over pi. Like we're going to divide by pi. So 24 divided by pi equals r. All right, give me an approximate for that. Bust out those calculators. I'm going to pause it. Okay, so then r is approximately 7.6, and it's feet. So our radius is about 7.6 feet. Very nice.
So actually, we didn't do one of those on our homework.
Would we check it?
Okay.
Could we check it?
You could check it. Uh-huh. How would you check it?
Would you put 7.6 where R is
Mm-hmm.
then multiply to see that it equals 4?
Yeah, so if you put in 7.6, you're going to get about r, or about 4. If you put in the 24 over pi for r, you will get 4. Does that make sense? So yeah, like if you do, so you would say, well, okay, 30 over 360, 2 times pi times 24 divided by pi. Because here, 2 times pi times 24 divided by pi, your pi's would cancel out. So then you'd have 30 divided by 360 times 2 times 24 is 48. And that should equal 4. So if you put that in your calculator, 30 divided by 360 times 48, do you get 4?
Times 48.
Mm-hmm.
I did something that way. Divided by 360.
I got 3.3. Okay, I was like,
I must have hit the wrong button.
no, I didn't get it. I got, what did we do wrong? I got 3.33. Is that what you did earlier?
I got a decimal. I got like 0.1.
Well, why'd we have to choose to check it? What on earth? Okay, it was 24 divided by pi. Do what? Okay, let's see. So 30 over 360 times 2 pi times 24 divided by pi. Okay, when I put the whole thing in, I got it to work. What did I do wrong? Oh, I put 40 instead of 48. 30 divided by 360 times 48 equals 4. Okay, I was like, what? All of my math is right, except the calculator is only as smart as the operator. I tell you that all the time. I put in 30 over 360 times 40 and not 48. So I kept getting the wrong answer because I kept inputting the wrong thing in the calculator, right? Operator error. You got it. My calculator was not... Do what? Oh. I was like, so my calculator was only as smart as I was in the moment, which was not very smart. All right, for example 3, we're going to mix it up a little bit. We're going to find the perimeter of sector XUY and segment XY. Dun, dun, dun.
Wait, I'm so confused. What?
Okay, so first of all, what's perimeter?
The whole thing.
You can't say the whole thing. That's not perimeter. What does that mean, the whole thing?
The whole sides.
The whole sides. What does that mean?
The X to U.
Does not mean my mom.
The X to U side, the U to Y side, and then the X to Y are.
Okay, so it's like the distance around. We add up all the sides.
No, not that side.
Okay. Why not that side? Tell me, why not that side?
Because it's a sector, not segment.
It's a sector, not a triangle, right? I did the triangle. Okay, good. You have to pay attention to the details. They always matter. We want segment or sector XUY, the perimeter. Okay? And we want the segment, the perimeter of the segment XY. Okay? So first of all, let's look at the sector. So this side is how long? 'Cause it's a radius, right? So how long is this side? 12, because it's a radius. So how long is the arc?
120.
That's the arc measure, not the arc length. Oh, no, we have to use the formula. Okay, so to find the arc length, we have to use the formula. Humpty Dumpty is going to be your best friend. That theta, he's a good old Humpty Dumpty. Okay, so the cool thing is we don't know the length of the arc measure, but we know everything else. Theta is how much? 120 times 2 times pi, and the radius is what? Times 12. Awesome. So 120 over 360, can we reduce that?
Length equals 1 over 3.
So 1/3.
Times 2.
Okay, so I'm going to go ahead and do 2 times
24 pi.
times 24 pi. 1/3 of 24 is
8.
okay, so our length is 8 pi. Perfect. So now that we have like this intermediate answer, we can find the perimeter of our sector. Okay, so this is all the sector, I should
So
say.
would it be 24 plus 8 pi?
Okay, where'd the 24 come from? But
The 12 plus 12.
okay, so 12 plus 12 is 24 plus 8 pi. So what is your
Approximate?
what's your approximate for that?
No, Lucas has already had.
49.
Lucas, shut up.
What are you turn off my calculator?
No, I like it, Lucas. I like that you are on fire. It is awesome.
I
Okay.
like that your calculator is on fire.
Oh, it's hot.
Well, it would be better if the calculator was on fire than Lucas, but he
Oh,
is.
I don't
Actually,
know about that.
You know what? I'm gonna gut you.
He's not a deer.
It's
Okay.
a dead joke.
Now, so we've done the perimeter of the sector. Now we need the perimeter of the segment, XY. The segment is X to Y and the arc length. We already got the arc length though, right? The arc length is 8 pi. So what are we going to do about the chord XY? How are we going to find the length to the chord XY?
Dead, you're up.
No, I'm not.
Yeah, you are.
No, I'm not.
Well, you're not now.
Okay, so there's a little hint here. A 120, 30, 30 triangle. That's what we have there, right? If the central angle is 120 degrees, the other two have to be 30 because this is a radius, right? It's isosceles. So the other two angles have to be congruent. This is old theorems, right? Coming back. We're still using all those old theorems. Okay? Is composed of two 30, 60, 90 triangles. My pen quit again.
Oh, yeah, you just chop it in half.
I can chop it in half. Okay? All right, so I am going to take this triangle and I'm going to cut it in half right here. And that's going to get me a 30. A 60 is going to be this angle because I bisected it, and this one is a 90. Sweet. Okay. So how does that help me? It doesn't. What do you mean? I'm gonna draw a picture. I'm gonna take some liberties here and draw myself a
Wait,
picture.
what's the hypotenuse?
So this is okay. So now this is 60, and this is 30, and this is 12. Okay, go again.
If you find one side, you'll find the other side.
If I find one side, I'll find the other side. What do you mean by that?
What was the
If you
hypotenuse?
find, since you split in half,
Mm-hmm.
they're congruent. So if you find,
Oh, if I find this side here, then it's going to be congruent to this side?
Yeah.
Yes. Excellent point. And so then I can add those together, right? I can add those together and get that whole length of XY. That chord segment XY. Good. But I got to find that half, right? Because we bisected it.
we do the x, 2x, and x squared, or
Oh, you are so close. You are so close. It is not the Pythagorean theorem. That's not what he's talking about.
30, 60, 90.
It's the 30, 60, 90. Get your reference sheet out. Look at the 30, 60, 90. What do we know?
1, 2, square root of 3.
Which ones go where?
1, 2, square root of 3.
Which ones go where?
1,
Oh, I was
2,
doing this
square root of
yesterday,
3.
wasn't I? On the
Where?
test.
You come point to me where 1, 2, and square root of 3 are.
But I'm right about that part.
You have the right.
Right idea with the wrong answer.
No. Which ones go where?
Square root of 30.
You're so, that's why I was like, you are so close, Lucas.
So 1, 2, square root of 3. Because that's the hypotenuse, so that's the last one.
Okay. So I'm going to change colors. What on earth does that mean? So he said it's 1, 2, square root of 3.
So x, 2x,
So
x, square root of 3.
if we find the square root, it's 12x.
He has the right numbers. They're in the wrong location. Look back at your theorem. Double check what it says.
Triangle is x, then the length of the longer leg, so 60 would be x square root of 3. Then
Okay. So 60 would be the square root of 3.
And 2x.
Okay. So it's 1x, 2x, and x times the square root of 3.
So would it be 6 equals x?
6 equals x. Yes, fantastic. Okay, because this one is 2 times x, so x has to equal 6. And so
I don't think that one does.
So then this one is what? Equal to 6 times the square root of 3. Because we just put, once we know x, we just,
10 point.
so this is 6 times the square root of 3. So what's the length of xy?
Approximately 10 point.
I don't want the approximate yet, not till the very end.
10 point.
No, I want the exact until we get to the end.
10.3923.
No, exact means I want the radical in it. Right? So xy, this is 6 times the square root of 3 plus 6 times the square root of 3. What does that equal? This is the same thing as saying like 6a plus 6a equals 12a. When we add radicals, they have to have the same radical for us to be like terms, for us to add them. So 6 times the square root of 3 plus 6 times the square root of 3 is equal to what?
12 square root of 6.
3.
12 square root of 3. Okay, so this is equal to 12 square root of 3.
No.
All right.
You want that approximate?
Okay, so now that we've got the length of this side, right? We just found the length of this. Whoops, that's an eraser. We just found the length of this chord is 12 times the square root of 3. And we know the arc is 8 pi. How do we find the perimeter?
Do you want the approximate for that?
Well, I want the equation first. Perimeter equals
12 times the square root of 3.
12
8
times the square root of 3 plus 8 pi. Totally weird looking. That is our answer, right? That is the exact answer. What is our approximate then?
20.8.
Is that your final answer?
No.
Okay.
Hey, come on. I was right.
See, I would have just put all this in the calculator at one time. I wouldn't have
Okay,
taken an intermittent stage. But that's okay. That's why I was like, is that your final answer? Use your calculator. I gave you a calculator. Quit being so lazy. Push the buttons on your
Plus
calculator.
25.1.
This one doesn't have the square
Hey,
root sign.
do that. Then do that.
That one does have a square root sign.
Does now
Or you could have just done 20.8 plus 25.1 because Caden's already done all the other work. 45.9. Woo, this was taking forever. Gosh, and it was feet. Yikes. Okay, so there is our approximate answer as well. Yikes.
You're a
Whew.
failure
Okay,
for getting the answer.
so nice job though. Like the hardest part was right in here and getting, how do I find that length? Oh my gosh. But nailed it.
No, we didn't.
Yes, you did.
What is pi negative
4. 3.14. Okay. Then we just have the next part. We just have a few more theorems to look at, and yeah. So we have that information stored in our brain. Congruent arcs. Okay. Are arcs on congruent circles or the same circle that have the same measure? Right? If you need a highlighter to highlight them or something. Okay. So what are the congruent arcs here?
A to B and C to D.
Okay, AB is congruent to CD. Remember how you would write that? So you would have AB, it's a minor arc with the arc over it, is congruent to CD. Okay, what's another set of congruent arcs?
XW,
Okay,
that be one.
XW and UV. Yeah, we could use those from the other one. XW and UV. So XW is congruent to UV. How about, are there any other congruent arcs on the circle, the two circles at the top? Circle Q and circle R?
So
The outside.
technically there is, but because you don't have another point, you can't actually say it.
Right, we can't actually, it's harder to name them. But yeah, we could look at the major arc across here. Right, those would also be congruent to each other. Okay, good. But yes, we can't really name them because they don't have a third point on there to name them appropriately. All right,
That point.
then some other theorems. Okay, in congruent circles, minor arcs are congruent if and only if the corresponding central angles are congruent. So we kind of use that today. Chords of congruent circles, again, or the same circle, are congruent if and only if they intercept congruent arcs. We learned the converse of that in 8.2, I believe. The next one, in congruent circles, chords are congruent if and only if the corresponding central angles are congruent. So the chords are congruent if the central angle is congruent, right? And then here above that we have, if the chords are congruent, then the arcs are congruent as well. And the last one, in congruent circles, two minor arcs are congruent if and only if the corresponding major arcs are congruent. So that's what we just talked about up here even, right? These two are congruent, so we said their major arcs have to be congruent as well. So, all right,